End behavior of polynomials. When we're discussing the end behavior of polynomials, it helps us to graph polynomials. And so we're looking for what does the polynomial do at the ends. We're not really worried about how many times it crosses the axis or bounces up and down. We're looking for what's happening on the left end, what's happening on the right end. Are they rising? Are they falling? Are they doing the same thing? Are they doing opposite things? And so the end behavior of a polynomial is based on the degree and the leading coefficient of the polynomial. The degree is the highest exponent. The leading coefficient is the coefficient of the term with the highest exponent. So for example, if I have a polynomial like this one, 3x squared minus 7 plus 5x to the fourth. To find the degree, I look for the highest exponent, which I notice is the 4. So if it helps, we can rewrite that polynomial with our exponents in descending order. So we would have 5x to the fourth plus 3x squared minus 7. Now we can see that my degree is 4, the highest exponent. And we can see that my leading coefficient is 5, the coefficient out front of the degree term, the term with the highest exponent. And so to find the end behavior of a polynomial, we're concerned with, is the degree even or odd? Is the leading coefficient positive or negative? And so to determine how that affects the end behavior of a polynomial, it helps to think about our most basic examples. So if we think about our most basic example where our leading coefficient is positive and our degree is odd, well, that would be y equal x. My degree is 1, which is odd. My leading coefficient is 1, which is positive. And we know y equal x looks something like this. And so if I'm observing the end behavior of this graph, I notice that it rises on the right and it falls on the left. So we would model that end behavior with a right arrow going up and a left arrow going down. Our most basic example of a leading coefficient that's negative and a degree that's odd would be y equal negative x. In this case, the graph looks something like this. And we notice in this case that my right end falls, my left end rises. So my right end would have an arrow going down, my left end would have an arrow going up, and this would model the end behavior for this equation. My leading coefficient being positive, degree is even. The most basic example would be y equal x squared. In this case, my degree is 2, my leading coefficient is 1. Degree 2 is even, 1 is positive, and so we know that the graph of this is a parabola opening up. And so when we're looking at what does it do on the ends, well, the right end rises and the left end rises also. And so this would be a diagram to model the end behavior here. Leading coefficient is negative, degree is even. Well, that would be y equal negative x squared. A parabola opening down. Again, to model the behavior, on the right end we fall, on the left end we fall. And so we can use this chart and these basic examples to help us remember what the end behavior does, or we can look at this chart and come up with some rules basically to help us. And so what we notice is that the leading coefficient being positive or negative the leading coefficient tells us what the right end of the graph does. So the leading coefficient gives us the right end. If the leading coefficient is positive, notice in both cases where the leading coefficient is positive, my right end rises. If my leading coefficient is negative, Again, here, both cases, my right end falls. And then the degree tells us how the ends behave together. The degree tells us how the ends behave together. So if the degree is odd, notice in both cases when the degree is odd, my ends are doing opposite things. So that if the right end falls, the left rises. If the right rises, the left falls. If the degree is even, again, notice in both cases, my ends are doing the same thing. They're either both going up or both going down. Which would tell me if my right end goes down, my left end has to go down also. If my right end goes up, my left end has to go up also. So we can use these rules or the chart to help us determine the end behavior of polynomials. So a few examples. Y equal 3x squared minus 7 plus 5x to the fourth. That first polynomial example we had. A couple more. 3x to the fifth minus 9x to the fourth plus 3x minus 2. Negative 3x to the fourth plus 6x to the third. And 10x squared minus 2x cubed minus 8x. So in the first case, we determined that my degree was 4, my leading coefficient was 5. With my leading coefficient being positive, that tells me my right end has to rise. With my degree being even, that tells me that the left end has to do the same as the right, so it must rise also. So this is what the ends of the graph of this polynomial will look like. Here, my highest coefficient, my degree is 5. My leading coefficient is 3. Again, my leading coefficient is positive, which means my right end rises. This time my degree is odd, which tells me the left end has to do the opposite, so it has to fall. Here, my degree is 4. My leading coefficient is negative 3. Negative for a leading coefficient tells me my right end falls. Degree being even tells me my left end has to do the same thing. And on the last one, I have a degree of 3, a leading coefficient of negative 2. Again, leading coefficient being negative tells me my right end must fall. Degree being odd tells me the left end must do the opposite, so it must rise. And we get the leading coefficient diagram for these 4 polynomials.